of quadratics. Okay, so we have looked at standard form extensively, and so what we're going to do is we're now going to look at a new form, and this form is called transformation form. Transformation form is a form that is used in order to give you all the information you need to graph a quadratic directly out of the equation without having to do extra work. The form is given right here, where we see that we have f of x equals a times x minus h squared plus k. Now there's a couple pieces of information that that equation tells you. First and foremost, it tells you which vertex is. So your vertex down here is the form hk. Second, it tells you whether you have a max or min. You're going to have a maximum value if your a is negative and a minimum value if your a is positive. That has to do with whether or not your graph opens up or opens down. Now the other thing that it gives you is it gives you what's called the axis of symmetry. Now this is a new concept. The axis of symmetry is this vertical line here, if you look at the example, that when it's graphed cuts straight through your vertex. The reason it's called axis of symmetry is because if you look at the right hand side versus the left hand side, they are exact mirror images of each other. Now in order to analyze and graph your quadratics, you have to be able to pick out and discuss all of those bits and pieces of information from your equation in order to get the big picture. Okay? With graphing, again, remember you're going to see your equations in two forms. The first form is that transformation form. So remember, that is f of x equals a times x minus h squared plus k. And from this form, again, you can pick out all of this information without having to graph it. And this right here, this is the important information that you have to analyze each time you do a problem. Now the other thing that Hawks is going to request or ask you to do is they are going to ask you to find two additional coordinate points beyond the vertex and the origin in order to graph your parabolas. So to do that, simply create an xy table where you choose your x values and you solve for y values, just like you would for any other graph. Now, what happens if you don't get transformation form? Well, that means you were given some form of standard form. And if that's the case, then you have to use the vertex formula, this formula here, where in order to calculate h and k, you calculate h by doing negative b over 2a, and you calculate k by doing your function evaluated at negative b over 2a. So we're going to look at a couple different examples. I want you to notice that these examples are slightly different from the ones that have been uploaded into the lecture notes previously. Due to the online classes, I did make some changes, so if you do have questions or want me to do the original examples, make sure that you make a note of that in the discussion board. So here we've got 1/2 times x minus 4 squared plus 3. So the first thing you have to do is you need to identify for yourself, is that transformation form or is it standard form? Well, in this case it's transformation form. If you look closely at the equation, notice it matches my transformation form here. Therefore, we can just simply pick the information we need directly out of the equation. Remember, your vertex is the point hk. So in this case, this means h is 4 and k is 3. Now the rule is this: if you're inside the bubble, the sign you see is opposite. If you're outside the bubble, the sign you see is the same. So here, because the 4 has a minus sign in front of it, it means the 4 is positive. If this had been a plus sign here, then that would have meant the 4 was negative. So pay very close attention to your signs. Now again, remember your axis of symmetry is that x equals h. So here you would have to write x equals 4. Not 4, x equals 4. Okay? Now my range in this case, because this is a positive graph, which means it opens up, my range is going to start at the k value and travel up to infinity. So this means I'm going to start at 3 and travel up to positive infinity. It also means that I have a minimum value at k equaling 3. Last, we have to do increase and decrease. So the first thing I'm going to do is just do a rough graph for you so that you can see what's going on. You want to start by graphing your vertex. So that's the point 4 and up 3. You want to graph in your axis of symmetry. So we're going to kind of graph that in there. And then if you're doing this on paper for me, all I care about is that you graph points in the right direction. Now remember, Hawks is going to ask you to find 2 additional points. So remember, just simply make that XY table where you're going to choose values for X. So you're going to choose these values here, and you are going to then solve for the matching Y values and then plot those points. But if you're doing it on paper, then I just simply care that it's kind of pointed in the right direction, and that's essentially that. Now, when we're talking about intervals of increase and decrease, you need to look at your graph. Now, what I like to say is this. Go ahead and stick your pen on your graph, and if it draws towards you, then you are decreasing. If you stick your pen on your graph and you're drawing away from you, then you are increasing. So here in this graph, we are going to use the X values. So here we're going to start by decreasing. So we're going to decrease from negative infinity all the way up to that X value being 4. Then we then change directions. So now we are increasing from 4 through to the positive infinity. And that is everything that you have to be able to do in order to analyze that specific equation. Okay? So here's where things differ. Here for this equation, we are going to look at graphing and identifying completely negative x squared plus 4x plus 5. Okay? So in order to do that, again, you first have to identify, are you in standard form or are you transformation form? And in this case, we're in standard form. Standard form then means that we have to start by using the vertex formula. So if you remember, your vertex formula is negative b over 2a, function at negative b over 2a. When we're looking at this, remember that first term is h, the second term is k, and you have to identify your a and your b. Now, you can identify them off to the side or not worry about it, it's up to you. I like to identify them because then I don't make any mistakes. Here my a is negative 1 and my b is 4. We then have to solve for our vertex using the formula. So my h value is found by negative b over 2a, which is going to be negative 4 over 2 times negative 1, which is going to give me positive 2 as a result. My k value is found by doing my function at negative b over 2a, which is the same thing as evaluating my function at 2. So if you remember from previous units, that means anywhere we have an x, we're going to substitute a 2. So this becomes negative 2 squared plus 4 times 2 plus 5. So when we reduce that, 2 squared is 4, apply the negative is negative 4. 4 times 2 is 8, so negative 4 plus 8 is 4 plus 5 gives you 9 as a result. So this means we found our vertex. So your vertex here is going to be the point 2, 9. From this vertex, again, we can write everything we need. Your axis of symmetry is going to be x equals 2. Your range, because this is negative, is going to start from negative infinity and go all the way up to your k value. So this means that range goes from negative infinity to 9. This also means that we have a max at k equals 9. And then our intervals of increase and decrease are going to be the opposite of the previous example. So let's graph it so you can see it. We're going to go over 2 and we're going to go up to 9. So there's my vertex way up there. Drop in your axis of symmetry line. And again, remember, if you're graphing by hand, I'm just looking for a rough sketch. So here you would kind of drop in negative down one side, negative down the other. So if we look, on the left hand side was where we start. We're going to start by drawing our pen away from us. So we're going to actually start here by increasing, and we're going to increase from negative infinity to your x value, which is 2. And then we're going to decrease from 2 to the positive infinity. So if you look at 2, we change directions, and now we come back towards us. So that is everything that you need to know about that second example. Our third example is slightly different still. If you look at it in this form, it is not exactly transformation form, nor is it standard form. So the first thing we actually have to do is we have to put it into standard form so we know what we're working with. Okay? So in order to do that, it means we got to take our equation, s of x equals x minus 4 times x plus 8 plus my 36. In this binomial piece, we have to FOIL. So we're going to go ahead and FOIL that together. Once you've done that, you should come out with x squared plus a 4x plus 4 being the result. Okay? So you're going to FOIL this together, add your 36, and you should get this as your result. Again, please double check my work. Now you can see that this is standard form. So to do that, we need to use your vertex formula. Again, as a reminder, that's going to be negative b over 2a, function evaluated at negative b over 2a. Again, remember the first part is h and the second part is k. So here we need to know a and b. And we're going to use this equation to find it. So here, if you look, my a is 1 and my b is 4. So here, h again is negative b over 2a. We're going to plug information in. Negative 4 over 2 times 1 gives you a negative 2 as a result. Your k is going to be the function evaluated at negative 2, which is going to be your choice. You can either go back to the original and use it, or you can use the equation you found. Both should give you the same answer. So for grins, we'll go back to our original, x minus 4 times x plus 8 plus 36, and we'll go ahead and plug into that. So here, this should be negative 2 minus 4 times negative 2 plus 8 plus 36, which gives us 0. We now have your vertex. So here, this is going to be negative 2, 0. Our axis of symmetry is x equals negative 2. Your range, again, because I'm positive, is going to go from your k value to positive infinity. So here, this is going to go from 0 to positive infinity. Means we have a min at k equals 0. And then here it means that we are going to decrease from negative infinity to negative 2, and we are going to increase from negative 2 to positive infinity. So let's go ahead and graph that so you can see what it looks like. Start with your vertex, negative 2, 0. Drop in your axis line, put it in the right direction. And we're good. Now, the last thing that we have to look at is we have to look at max and min problems. These are going to be application problems using quadratics, but specifically we're going to be looking at the vertex formula. Okay, so here we are essentially going to use your vertex formula to solve each and every one of them. Okay, so we're going to look right at that. The first one says the total revenue for Thompson's studio apartments is given by the function, where x is the number of rooms rented, and then the question says what number of rooms rented produces maximum revenue. So we kind of have to know what formula or what part of the formula is necessary. So remember I said you're going to use the vertex formula. Your vertex formula, again, negative b over 2a, function evaluated at negative b over 2a. So let's look at what this formula actually tells you. H, or this first part, is essentially the number of units needed. The second part here is going to tell you your max or min revenue. Okay? So, in this problem, we want number of rooms. So we only actually care about this h value part of the vertex formula. So here we need to take our formula, and I would rewrite it so that it is actually in standard form, negative 0.1x squared plus 100x. And then you're going to use the part of the formula that matters the most. So we want your h value, which is going to be the number of rooms. So this is going to be negative b over 2a. In this case, negative 100 over 2 times negative 0.1, which gives you 500 as an answer. So here we are looking at 500 rooms needed. And that's it. The second example says that the revenue function for a bicycle shop is given by the following function, r of x equals x times p of x, where x is the number of units sold and p of x equals 400 minus 0.2x, which is the unit price. And this one wants us to find the max revenue. So again, we need to take a look at what do we know. Well, negative b over 2a, function at negative b over 2a. Again, what does this tell us? Well, this part here is going to tell us the number of bikes, and the second part here is again going to give us max revenue. Well, in order to calculate max revenue, we have to know the number of bikes first. So we got to start with our equation. R of x equals x times p of x. Well, I've given you p of x, so here's your hint. All of these should be quadratics, and if you look at this equation as a whole, it's not quite a quadratic yet, so we have to make it that way. So that means this is going to be x times 400 minus 0.2x, which is actually going to give me 400x minus 0.2x squared. Now that we have our quadratic equation, we can actually use the formula. So, my number of bikes is going to be negative b over 2a, so negative 400 over 2 times negative 0.2. And so this is actually going to give me a rather large number. That number is 1,000. So then, to find my max revenue, says I need to do the function evaluated at negative b over 2a. So my function evaluated at 1,000. So this is going to be 400 times 1,000 minus 0.2 times 1,000 squared. And yes, you should get some rather large numbers at times, and this is going to come out to be 200,000. Now, since max revenue is what we wanted, that's why we had to do the second step. Our last and final example, again, is going to bring us back to our stone example. So here a stone is thrown directly upwards from a height of 30 feet with an initial velocity of 60 feet per second. The height of the stone t seconds after it has been thrown is given by the following function, where v naught is velocity, h naught is initial height. Determine the time at which the stone reaches its maximum height, and then find the maximum height. So again, we need to look at what it is we know. So negative b over 2a, function at negative b over 2a. Again, if we look at that, this first part here is going to give me my time. Second part here is going to give me my max height. So I have to start with my equation. So h of t equals negative 16 t squared plus my velocity was 60, so 60 t, plus my height was 30. Now here, notice we're going to write our answer in decimals. So when we're looking for our time, again, negative b over 2a. So negative b over 2a is what we're going to use. So this is going to be negative 60 over 2 times negative 16. And this should give you 1.875 seconds. Now, do not round. Use this decimal as it shows up in your calculator. If you round at this point here, then your maximum height will be wrong. So do make sure that you use whatever decimal you've been given. Now, to find your max height, again says we're going to do the function evaluated at whatever our time was. So here, this is going to be negative 16 times 1.875 squared plus 60 times 1.875 plus 30. Use your calculator and you should get a decimal answer of 86.25 feet. So this is everything that you need to know out of 3.2. Remember, once you're done viewing this video, you need to make sure that you go into that discussion board and you need to answer the questions there that are related to 3.2. If you have any questions or concerns, make sure you relay those into that discussion board, as that is going to help tailor our virtual classroom, which again, if you remember, will meet on Wednesday.